Hello students, in our last lecture we studied about kinematic equations and we have obtained three kinematic equations using graphical method. Now in this lecture we are going to study another method of obtaining kinematic equation. This method is known as method of calculus. Now here a new type of mathematics is used. Earlier, we have studied about the differentiation. Now, we will study about integration. So, first we will study about the basic rules for integration, and then we will apply that rules of integration to obtain kinematic equation. So, this method is called method of calculation, that is using method of integration or differentiation. Now students, some basic formulas for integration. We have studied earlier that if it is d by dx of any constant, then that is equal to 0. But here in integration something reverse. In integration of any constant is c into x. Here the integration is with respect to dx, and so c is already there and we have to multiply x because integration dx is there. Students, remember in differentiation we will get this type of term compulsory, d by dx. Then whatever is to be differentiated, that is written here. Similarly in integration there will be compulsory like this term integration dx, and there will be some term here which is to be integrated. So here the function is x. Here also the function is x. If I write d by dt, then the function is t here. If I write integration dt, means function is t here. So now let us start with first integration of any constant. Function is dx. So a constant into x. Next, number 2, integration of x raised to n. Now here remember that the power is increased by 1. So x raised to n plus 1 upon whatever there is power, that is in the denominator. Students, remember that what we did in differentiation. For the differentiation of x raised to n we did like this, d by dx of x raised to n is equal to, what we did, we kept this n in multiple, that is n, then x raised to n minus 1. But here something reverse. What we are doing, we are adding plus 1 to n in integration. Here in differentiation it was minus 1, but what we are doing here, here we are adding plus 1, and whatever there is in power, that is in the division. In differentiation it was in multiplication, here it is in division. So once again students, integration of x raised to n, just increase the power of x, so it will be plus 1. Then whatever you see here, you have to write in the denominator. So we have to divide it by that power. Now integration of 1 upon x is ln x. Integration of 1 upon x is ln x. Now students, you might be knowing what is this ln. Ln is a natural log. Generally, we used to write, suppose, log of 5. In this normal log, here at the base there is 10. So we don't use to write that 10 here. But whenever there is ln, means it is a natural log, and this natural log means it is log to the base e. So if I write ln x, means it is log to the base e of x. Now next, integration of e raised to x dx is equal to same e raised to x. Let us recall differentiation of e raised to x. Students, we know that if it is d by dx of e raised to x, then what we have to write here? We used to write here e raised to x only, no change. So in integration also same thing, no change. Let us take some example related to this integration. In integration, there are limits from where to where we are integrating. So here you can see in this example, here we have to integrate 5x cube. Here there will be dx. So integration of 5x cube, where the limit is 2 and 4. This is called a lower limit and this is called upper limit. So now students, remember, we have to integrate this. So 5 is a constant but having a function with it. So we will put this 5 outside. So we have taken this 5 outside. What remained inside? X cube. Now what is integration of x cube? We have to simply increase power by 1. So this 5 is in multiple, which was constant, this, and x raised to 3 plus 1, we have increased by plus 1, and whatever there is in the power, that is to be divided. The same thing which we have studied in that rules, second rule. This is our second rule. You can see here, same thing we are applying here. So we have applied that. Now we have to put the limits, lower limit and upper limit. Next is to put the limits. We have already integrated this. Now simplification by using mathematics. What is here now? It is x raised to 4. So it is there. 3 plus 1, 4, it is here. Now first we will put upper limit and then minus lower limit. Always remember students, upper limit minus lower limit. So 5 is there, 4 is a number, so we can take it out. So we have taken out 4. So it becomes 5 by 4. This, what remain in the bracket? X raised to 4. Now we are going to put the limits. In place of x, first we will put the upper limit. So 4 raised to 4. In place of x, we are putting this 4. Then minus lower limit. Now in place of x, what we will put? We will put lower limit, that is 2. So 2 raised to 4. So upper limit minus lower limit means in place of x, we will put first this upper limit, that is 4. Then the lower limit 2. Now this type of simplification you can easily do. 4 4s are 16 into 4. into 4. Why? Because power is 4. So 4 into 4 into 4 into 4, and this 2 into 2 into 2 into 2. Then subtract this term from this term and then multiply it by this. You will get 60. So students, I hope this is not needed to be explained, that how this 60 came from this. That is not needed at all. You can easily do it. Now let us start with the kinematic equations by another method. So students, this is an example number 3.3, but it is like a theory, and very important theory to be asked in examination. Now let us start with what we know. We know that acceleration A is equal to dv by dt, that we have studied in the topic of acceleration. We call this as instantaneous acceleration, or simply acceleration. Change in velocity upon change in time, but this dv means it is very small change in velocity, dt means very small change in time. Now we know that kinematic equations are always for constant acceleration. So here we have mentioned that A is constant. Let us give this equation number 1 so that it can be used later on if required. Now students, this can be read as d by dt of v, d by dt of v, or differentiation of velocity with respect to time. Here the function is time. So velocity is a function of time, means velocity changes according to time. Now next step, we have simply made the subject dv. So this dt will be towards left side, so a into dt. So dv is equal to a dt. Now this is for very small change in velocity to the very small change in time. But now if we want to find for the entire change, means once again students, if I want to find from this velocity, suppose v1, to this velocity v2, from here to here there is a change in velocity. Here suppose the time is initial time t1, and suppose if this time is t2. So what we have done here, we have obtained for this small part, means for very small change, not for this entire change. So first is for small, and then we will integrate to find the entire change. Are you getting students? Integrating for overall change. This is for very small change. Now, so to find the entire change or total change in the velocity with respect to that given total time, integrating both the sides of this equation. So students, see, the sign of integration is made in the above equation. So now when we integrate, we have to put the limits. Initial velocity v0, final velocity v. This is lower limit and this is upper limit, because this is the term for velocity. Here the term is for time. So here also integration, initial time 0, final time t. When the velocity was v0, that is initial velocity, at that time the time is taken initial time. Now we have integrated this term on both the side like this. So we got this term. Now next term, What is integration of dv? So students, recall that integration. We have given that formula, that integration of dx, where x is a function here, then it will be x. Integration of dx is x. So here what is there? Integration of dv. Integration of dv is v, and bracket is there to put the limits, lower limit and upper limit. So limits of integration is kept. Now here, what is a? A is a constant, so we have kept that constant outside. What is remain inside? So students, look at this term. A is taken outside. What is remain inside? Integration of dt. So what is integration of dt? Here the function is t, so integration of dt is t. As we have seen that integration of dv is v. Similarly, integration of dt is t, and these are the limits, lower limit and upper limit. Now next step is to put the limits. Once we will put the upper limit, that is in place of v we will put this v, so we have kept here. Then minus lower limit, so in place of this v we will put v naught, so we have kept that only, so v minus v naught. Next is a is already constant, so now in bracket, in place of t we will put t, that is upper limit, so we have kept here, minus, now in place of t we will put lower limit, which is 0, so minus 0. Now next is quite simple. What is here? V minus v naught, and here it is only a into t, because a into 0 will be 0 only, so a into t, and here it is v minus v naught. Bringing this v naught on right hand side, minus v naught will become plus v naught, and at is as it is. So we get this equation, v is equal to v naught plus at. This is the first kinematic equation, which we also obtained in the graphical method. So let us give this equation number 1, first kinematic equation. Now again, velocity v is equal to displacement upon time. What is this v? It is instantaneous velocity, or simply velocity, and we have studied in our earlier lecture that v is equal to dx upon dt. Small change in displacement to the small change upon time. Now students, first equation is obtained by using equation of acceleration. Now second equation will obtain by using equation of velocity. Now next is to make the subject dx. We will bring this dt this side, so dx is equal to v into dt, but this is for very small changes. Now to find the entire change, we will integrate as usual. So now students, remember what we did here, the same thing we are going to do here. So we have put the sign of integration on both the side, so here we have kept sign of integration. Here it is function of x, so initial position and final. Initial position is taken x naught and final position is x. Here the function is time, So initial time, as usual, we used to take 0. Final time is t. So this is called a lower limit. This is upper limit. So here also lower limit and upper limit. But students, in integrating that previous terms of acceleration, we have kept acceleration outside the integration because it was constant. But here this v is not constant, it changes with time. So it is a function of time. So here the integration will be little different for this. Now let us start integration. For this first term, as usual, integration of dx is x, and these are the limits, is equal to integration of this. Students, from equation number 1, we will put this v. What is v? V is equal to v naught plus at. So we'll put v naught plus at in place of v because of this equation number 1. So we have done this only. You can see here, in place of v, we have kept v naught plus at from equation 1. Now v naught initial velocity is constant. So integration of constant. Students, once again look here. First we'll integrate v naught, then integration of at. So for integration of v naught dt, that is for this first term, v naught dt is equal to, as this v naught is constant, we'll take it out. What is remain inside? Only integration of dt. And what is integration of dt? Integration of dt is simply t. So we'll get integration of first term as v naught into t. So we have kept here. Now for second term, integration of at. So once again look here, integration of at dt. We used to write like this because we are doing separate integration. So a is constant, so it is taken out. This a is constant, which is taken out, and now what is remain inside? Only t dt. Integration of t is t square by 2. Students, remember, if there is nothing here in power of t, means it is 1, and we know that integration for power 1 power is increased, so 1 plus 1 is 2, and whatever is here we have to write in the denominator. So our integration for this term will be at square by 2, and so is this. So I have separately explained for this first term and second term, but here I have written combined. Now bracket, and this is the lower limit and this is the upper limit, you can see here. So we have kept that. Now I hope you understood till this. Next is, in this term, first we will put x in place of this, that is upper limit, so it is x only. Then in place of this x we will put x naught, but there will be minus sign. Why? Because upper limit minus lower limit, so it is x naught. Similarly, in place of t we will put t, so it is here also t and it is here also, so it is t only, so we'll put that only v naught t plus half at square, that is upper limit, minus lower limit. So in place of t, now if we'll put the lower limit, that is 0, then 0 into anything will be 0. Here also in this second term also there is t. So we'll put 0 here in place of t, but 0 into anything is 0. So here we can say that this is for the upper limit which we have put this t, minus lower limit is 0 only. So we have not shown this 0 here. So we have kept this. Now simplification. Just make the subject x. So here this x naught will be on this side. So it will become plus x naught here. But say students, what I have written here, if we consider the initial position to be 0 at time t is equal to 0. So considering this initial position 0, if this is 0, then only remained is x is equal to v naught t plus half a t square. This is the second equation of kinematic. Now for last equation, that is third kinematic equation. What is acceleration? It is dv by dt, which we have used earlier only. That is equation number 1. Now students, after this step, for this term I have written this term. Now you can see here in this term there is no dx, but I have included that dx here. So dx is multiplied also and dx is divided also. Now students, look here. If it is 5 by 2, then can I write this 5 by 2 as 5 by 3 into 3 by 2? Just tell me. These two are equal or not? So we'll find that these two are equal only, because again we can set 3 cancel, and this results once again 5 by 2. So if I write this 5 by 2 in this way, 5 by 2 and multiplying and dividing by 3 and writing the same term in this way, so that is correct only. So here also what we did, we have multiplied by dx and divided by dx and then written this like this. So you can see here it is dv upon dx into dx upon dt. This dx is multiplied and divided. Rest of the things is as it is. dv is already there in numerator and dt in denominator. So I hope you understood this, why we have written this like this. Next step, what is dx upon dt? So equation 2 says that displacement upon time, that is dx upon dt, is v, velocity. Equation number 2, let me show you. Equation number 2, it is here. Say v is equal to dx upon dt. So in place of this dx upon dt we can put v. So we have did that. Now in our next step we have brought this dx towards left side. So already there is a. So a into dx. What is remained here? dv into v. Now this is for very small changes to integrate to get entire change. So we have integrated this equation on both the sides. Now integration is done here. Here it is function of x. So limits will be x naught, that is initial position to final position. So same thing we have done here. Here it is function of v. So initial velocity and final velocity. Next is to integrate it. Now using the formula for integration, we know that a is a constant. So as this a is constant, we have taken it out. What is remain inside? Only integration dx, and integration of dx is x, lower limit and upper limit as usual. Now it is v dv. So here what is the power of v? It is 1. So when we'll integrate, the power is increased by 1. So already 1 is there. So 1 plus 1 is 2. So power is 2, and whatever is here is divided. So here integration of v dv is v square by 2, and then putting these limits, initial velocity and final velocity. So I hope you understood this also. Next, a is constant, it is outside only. Once we'll put x in place of x, that is upper limit, minus x naught in place of x. Similarly, this 2 which is in denominator is taken out. What is remain inside? V square. So upper limit, that is v. So in place of v we'll put v only. So it is v square minus, in place of v we'll put v naught. So it is v naught square. Now this 2 is brought towards left side. So it is 2a in bracket x minus x naught. Now what is remained on the right hand side? It is v square minus v naught square. Next step, as usual, what we did earlier, we have taken this initial position as 0. So considering this initial position as 0, what is remained on left side? It is 2ax. So is this, and here as it is. So this is our third kinematic equation. So students, we obtained 3 kinematic equations by using method of calculus. Now students, what we have considered here, initial position to be 0. But if we'll not consider initial position to be 0, then equation number 2 and 3 can be written as like this, and that you can easily understand from that earlier process or the method which we have done. Now next is example number 3.4. Before I start this example, I want you to go through the statement. Students, always read the statements one time. If you are not able to understand the statement, then read it 2 times, 3 times. But it is required for you to understand first the given condition. What is given in the statement and what is to be find out. Now students, here it is given that a ball is thrown from the building. So from this point, a ball is thrown in the upward direction and its velocity is 20 meter per second. So with that initial velocity, a ball is now moving in the upward direction. Height of the building is given 25 meter, means this is the height of the building. Now ball will move in the upward direction, its velocity will go on decreasing. At some instant, at some height, its velocity will become 0. and then once again it will move in the downward direction. So here from figure it is clear that to move from this point to this point, it takes suppose time t1, and this much distance from the top of the building to this point where the velocity instantly becomes 0. That height is taken as y1. So here what we have to find? Here we have to find that height y1, that is this much. Also we want to find the time. Which time? So we want to find the time when the ball is thrown in the upward direction. That means it will move in the upward direction, then once again it will move in the down direction and it will reach the ground. So we want to find time for this path from the top of the building in upward direction, then it will move in the downward, and once again it will reach at the ground. So this time we have to find. Now students, acceleration due to gravity. Here the acceleration is due to gravity. We have to take it as 10 meter per second square. Actually value of g is 9.8 meter per second square, but here we have to take it as 10 meter per second square because it is given in the statement. Now here remember, in solving this type of examples we have to follow Cartesian sign convention. Means during the upward motion the velocity is taken as positive. If the motion is in the downward direction, then velocity is taken negative. Moving in the upward direction, displacement is considered positive. Moving in the downward direction, displacement can be considered as negative. But always acceleration due to gravity is taken negative. So students, this thing we have to take in consideration. Now first we need to find this distance y1. Remember students, this distance y1, that is this much. So distance is to be obtained, acceleration is known to us, initial velocity is also given, final is also given. So by using kinematic equation we can easily find that distance y1. So we have that equation number 3, that 2ax is equal to v square minus v naught square. This is equation number 3. But here displacement is in terms of y1, so in place of x we have used y1. Rest of the things as it is. Now next, just put the values. Acceleration is minus 10. As I said earlier, acceleration due to gravity is always taken negative. Then this is to be obtained, so as it is, initial velocity was given, it is 20. So in place of v naught we have written 20, and when the ball will reach at the maximum height, its velocity, that is final velocity, will become 0. So final velocity we have taken 0. Now the calculation is quite simple. Just make the subject y and calculate it. We will get y1 is equal to 20 meter. Now students, once again about how we can use the sign for these given values. Students, here we know that time is always positive, time can never be negative. So time we will always use positive only if it is given. Second thing, here we have taken acceleration negative. It is because when the ball is thrown, the initial velocity was large, and as it moves up, its velocity goes on decreasing. So if we take the final velocity minus initial velocity, then it will become negative. Because velocity decreases, the final velocity minus initial velocity will be negative. And we know that acceleration is change in velocity upon time, and that's why acceleration here we have to take negative. Second thing, displacement. Moving in the upward direction means it is positive y direction. So we will take the displacement positive. If the object is moving in the negative y direction, then we can take that displacement negative. Now students, one thing more, that how we will know that which equation is to be used out of three equations. We know that the first kinematic equation is V is equal to V naught plus AT. Now what we want to find here? In first part we want to find the displacement, and you can see that in this equation there is no term related to displacement. Here this is final velocity, this is initial, this is acceleration, this is time. The thing which is to be obtained or to be find out is not there in this equation. So we cannot use this first equation. Then second equation, we have the equation x is equal to V naught t plus half a t square. Now here we cannot use this equation also. Why? Because displacement is to be find out. So here this displacement is not given, this is to be obtained. So other things should be given. If all these other things are given, then we can easily find the displacement. But here this t is not given, and so we cannot use even this equation to find displacement y. Then only third option is remained. It is 2ax is equal to v square minus v naught square. So initial velocity it is given, final velocity that we know that at maximum height it will be 0. So these two are known, this is number only, and acceleration is also given. So only unknown is displacement. So this equation we have used here to find the displacement y1. Now next part is to find the time. Now students, what here we have to do is, we know that we have to find the total time for that object which moves in the upward direction, that is this time, which is t1, and then from upward to ground, that is time t2. So we will find time t1 also, we will find time t2 also for downward motion, and then we will add this both the times. We will get the total time for upward and then downward. So total time can be calculated. So now to find time t1, which equation we will use out of three equations? So once again students, carefully see. First equation is v is equal to v naught plus at. Time is to be find out. Acceleration is given. Initial velocity we know, that is given. Even final velocity is also known to us. So we can use this equation to find the time. Also, let us try second equation. X is equal to v naught t plus half at square. Can we use this equation to find time? Displacement, that is y1, we know. Initial velocity is known to us. Acceleration is also known to us. So only time t is unknown. So even we can use this second equation also. But which one is easy out of these two? So definitely it is clear that this equation seems to be easy. So we will use this first equation to find time t1. Why we cannot use third equation here? We know that the third equation is 2ax is equal to v square minus v naught square. In this equation there is no t, there is no time, and that is to be obtained. So as there is no time in this equation, we cannot use this equation. So now using first equation, v is equal to v naught plus at. But which time we want to find? For upward motion it is t1. So we have written here t1. Final velocity is 0 at maximum height. Initial velocity is given 20. We have taken positive because moving in the upward direction. Acceleration, as I said, always negative when it is acceleration due to gravity. T can be obtained. So T is obtained to be 2 seconds. So first time, that is for upward motion, is obtained. Now for downward motion, for path AB, let me show you from the figure. Students, you can see this is point A, and in the downward motion it reaches the ground, that is point B, and we want to find time t2 for this path. Now students, here initial velocity is 0 at point A. Acceleration is due to gravity, that is also known, and we want to find this time. So initial velocity is known, acceleration is known, and we want to find the time. So which equation can be used? So you can easily make out that only this equation can be used. Initial velocity is 0, acceleration is 10, displacement y2, it is taken minus 45. Now why it is 45 and why it is negative? Let me show you. Students, we have already obtained this displacement, that is 20 meter. Y1 is 20 meter. So now you can see in figure this much displacement, that is y1, that is 20 meter. Height of the building is given 25 meter. So 20 plus 25, that is 45. And why it is negative? Because we are moving now from upward to downward direction, and so it is negative y direction, and so displacement is taken negative. So here y2 is minus 45, initial velocity is 0, acceleration due to gravity is minus 10, rest of the things as it is. So you can see only t2 is unknown. So mathematically solving, you will get t2 square is equal to 9, and therefore taking square root we will get t2 is equal to 3 seconds. Now we have already obtained time t1, which was 2 seconds. We obtain now time t2, which is 3 seconds, and so total time t is equal to t1 plus t2, that is 2 plus 3 is equal to 5 seconds. So I hope students you understand this. Now this B part, that is to obtain the total time for an object to reach the ground, can be calculated in another way. In this method, directly we can obtain the time. That means there is no need to find time t1 and then t2 and then to add both. Directly we can find the time. So what we have done here, using this equation, that is equation number 2, kinematic equation number 2, y is equal to v naught t plus half at square. Students, here we have taken this y as minus 25. Now I will show you why it is minus 25. So once again move to the figure. Students, the object is thrown from this point. It will move in the upward direction and then it will come down. So if we'll start our process from this point only, then initially it is here, object is here, finally it is here. So initial to final, how much distance is this? It is 25, and so we have taken it as 25. So displacement y is 25, but it is in the downward direction finally, so minus. So using this equation, that is y is equal to v naught t plus half at square, we have taken y as 25 negative. What was initial velocity at that point? It was 20. So we have written v naught as 20, t is unknown, so as it is. Acceleration due to gravity is always minus 10. Solving this, we'll get a quadratic equation whose variable is t. And we know that there are two solutions for any quadratic equation. So here, solving this quadratic equation, one value of t is obtained to be 5 seconds. For this term, we will get t is equal to 5 seconds, and for this term you will get t is equal to minus 1 second. So we got two times. One time is 5 seconds and the other time is minus 1 second, but we know that time can never be negative. So this is not possible, and so t is 5 seconds. So we can do this second part, that is B part, directly also. Students, if you are not able to understand this example, watch this video second time. I make you sure that you will be able to understand it. Also, solve two or more examples of this type which are given in your exercise of this chapter, so that you can easily understand this type of sums or the examples.